Hello everyone! Today we are going to talk about a common object in each home, the electric iron. We will explain it based on a physical phenomenon. So, how does this object work? We'll see how electricity becomes heat, how the temperature stays stable, and how heat plus steam plus pressure make clothes smooth. It all starts with electricity. When you plug in the iron, electric current goes through a special part, the heating element. This is usually made of nitrile wire, a mix of nickel and chromium. This wire has high resistance, so the current has difficulty passing through it. This process creates heat. This is called the Joule effect. Formula simple. Heat is equals to current square times resistance times time. In a normal iron, the wire gets very hot, up to 800 to 900 degrees Celsius, but it doesn't melt. This heat goes quickly to the metal base, the plate, by conduction. But how is it possible that the iron doesn't get too hot and burn everything? There is a thermostat. It's a clever part with a bimetallic strip, two metals together. When it gets hot, one metal expands more and bends. This breaks the electric circuit. The heat stops. When it cools, it goes back and the heat starts again. This keeps the temperature at the right level, between 120 and 220 degrees Celsius for different clothes.
Now we know how heat is made and controlled. Let's see how the heat reaches the clothes and what's happening inside. The main mechanism is conduction. The hot metal plate touches the fabric directly. Heat moves very fast because metal is a good conductor. In steam iron there is something extra. Steam. Water in the iron becomes hot and turns into steam. When steam touches cold cloth, it changes back to water and gives a lot of extra heat. This is called latent heat. Steam also makes the fabric wet. This is help a lot. What happened to the fabric? Clothes are made of long chains, polymers, in cotton, polyester, wool, etc. When clothes are wrinkled, their chains are stuck in incorrect position with hydrogen bonds. Heat and steam makes these bonds weak. The pressure from the iron and your hands stretches and straightens the chains. When the clothes cool down fast, new bonds form, but now in the straight position.
To sum up, it is important to realize that the electric iron is a perfect example of how physics is not only found in textbooks, but also in our everyday lives. In just a few seconds, several physical phenomena occur at the same time. First, the Joule effect takes place, where the electrical energy is transformed into the thermal energy inside the nichrome resistance. Then, this heat is transformed with thermal conduction from the metal subplate to the fabric. At the same time, the bimetallic thermostat regulates the temperature through thermal expansion, preventing the clothes from burning and ensuring that each type of fabric receives the appropriate amount of heat. In steam irons, the process is even more efficient, since the latent heat of the steam allows the fibers to relax more easily. This, combined with the mechanical pressure we apply while ironing, helps stretch and reorganize the polymer chains. Finally, when the fabric cools down, the bonds form again and the clothes remain smooth. In conclusion, an iron demonstrates how electricity, thermodynamics, and mechanics work together to solve an everyday need in a simple and efficient way.